Hi, once again, everyone. Welcome back to our statistics class notes. We're in section 8.3, where we're trying to wrap up our study of hypothesis testing for population proportions. And I just got a few cautions here for you in this page. We're on the top of page 130 again. So beware, cautions about writing your conclusion. So because we can never be 100% certain that our conclusion in hypothesis testing is true, when your p-value is greater than your significance level, avoid using any of the following phrases, right? We don't say things like we accept HO. Instead, we say we do not reject HO. We don't say we have proven HO to be true because we're never 100% certain. So we say we have failed to reject HO. We do not reject HO. We have failed to reject HO. Those are fine. We don't say we accept it, or we don't say we have proven it to be true. Okay, so let's look at this example where these are kind of similar ideas here. An infomercial advertisement claims that a Himalayan salt lamp can increase energy levels in people who use it. A medical researcher tests this claim with 326 people who claim to have low energy. He randomly assigned half of the group to use a genuine Himalayan salt lamp for 4 weeks and assigned the other half of the group to use a look-alike lamp for the same time period. After the 4 weeks, he surveys participants in both groups on their energy levels. After analyzing the data, he fails to reject the null hypothesis. Okay, so he fails to reject the null hypothesis. So in other words, he is not going to be able to show that the Himalayan salt lamp can increase energy levels. He cannot statistically provide evidence to demonstrate that that could be true. So which of the following are valid interpretations of his findings? There may be more than one correct answer, and in this case there is. So part A says the Himalayan salt lamps are not effective at increasing energy levels. That's too definitive. That's almost like we've proven it to be true that they're not effective. So that's like accepting that HO, the null, that Himalayan salt lamps are no more effective than any other kind of lamp. So that's too definitive. What we should say instead is there's insufficient evidence that the Himalayan salt lamps are effective at increasing energy levels. Another example of a statement that's bad is the Himalayan salt lamps had exactly the same effect as the look-alike lamps in increasing energy levels. Again, that's not true. We're not saying it has exactly the same effect. We're saying that there's not enough evidence to show that the Himalayan salt lamps are statistically significantly more likely to increase energy levels than the look-alike lamps are. So what we want to say is there were no statistically significant differences between the Himalayan salt lamps and the look-alike lamps at increasing energy levels. And then I've talked about this many times in class, but I want you to understand what's the difference between a confidence interval and a hypothesis test. So they're closely related, but they do ask slightly different questions. Remember, a confidence interval gives us a range of plausible values for the population proportion P, and that range is P hat minus M to P hat plus M. A hypothesis test, however, starts off with a null hypothesis, P equals P naught, and then has one of 3 possible alternatives. Either P is not equal to P naught, or P is less than P naught, or P is greater than P naught. So what a hypothesis test is doing, is saying, is the data consistent with the population proportion P being a specific value, P naught, the null, or might it be something different? That would be P not equal to P naught, or it could say, or might it be something smaller? That would be P less than P naught, or might it be something larger? That would be P greater than P naught.